Okay, welcome to Probability and Statistics. We're going to do unions and intersections here again. So we have some basic probabilities up here. Probability of A is equal to 0.3, probability of B is equal to 0.2, and the probability of the intersection of A and B is equal to 0.1. You can't actually calculate this from this technically because you don't really know what the state space are of any of these. So you can't say, oh, well, these overlap by zero point 0.1 or whatever it is. So this information is really critical in the problem. If for some reason it wasn't given by your professor or something, most of the time you can kind of say, well, this minus this will equal the probability of this. But that is not a rule at all. Don't ever try to do that because that's not a set, hard rule. This information needs to be given if this is all that you have. But we don't have to worry about that. So just jumping right into this. The first part of the problem is the probability of A naught. Well, this is actually pretty easy. So not A is whatever's outside of this 0.3. So if you want to see the equation for that, you can see that it's 0.7 just from that, but really the equation is 1 minus the probability of A, which is 0.3, which is equal to 0.7. So that's the probability of A number. So that's how you solve it. If you're trying to find the rest of something, just take 1 minus 0.3, because any set of probabilities has to equal 1. Okay, moving on. So now the probability of A union with B is equal to, alright, so A union with B is a combination of A and B. So if we're going like this, it's going to be the probability of A plus the probability of B. Okay, that's pretty good. But here's a little trick to this. When you're doing a union by addition, you have to subtract the probability of the intersection. A intersected with B. So, the reason for this, imagine if you had a group of state spaces like A1, A2, A3, A4. And these are not the probabilities, these are just variables. Let's say they're lined up like this, and say this column is the probability of A, this column is the probability of B. The probability of A is A and A3 combined out of 4. And the probability of B is A1 and A2 out of 4. But you see we're counting A1 twice. You can only count A1 once when doing the probability of a union. So the probability of the intersection of A and B, you subtract one of those, and now you just have A3, A1, A2, as opposed to A2. If you were just to get rid of this subtraction, you just have probability of A and probability of B, then you'd have A3, A1, A1, A2. So you count A1 twice unless you subtract it out with this intersection. So that's why we have to add that in there. And if you add that all up, it's 0.3 plus 0.2 minus 0.1, all information given up here in the top, which is equal to 0.4. So, moving on, the next one we have is the probability of A naught intersected with B. Okay? So, the one you use for this, the kind of formula you use, is the probability of A naught times the union of B plus the probability of A times with the union of B. Oops, sorry. It's not a little small a, that's just the union symbol. Union with B is equal to P of B, probability of B. Now, so you might ask, well, why can't we use the 0.7 that we had up here and the B that was given? Well, again, because these are already probabilities. If we had a state space, that would be possible. But since we only have the probabilities, we have to work only within the probability symbols. So we're looking for probability of A naught times B. So we use the property of A naught and A both intersected with B equaling just B. Because we have B and we have A intersected with B, we just need to find this. So the probability of A naught intersected with B is equal to the probability of B minus probability of A intersected with B, which is equal to 0.2 minus 0.1, which is equal to 0.1. So that's the probability of A not B. So you have to use this property right here. This is kind of a distributive law of, or a cancellation law of statistics. I'm not going to go into details of this. It's in your book. So just go ahead and take a look at that. But this is a quick little property to get that figured out. So now, the next part of the question is the probability, which is the probability of A intersected with B not. So we've just switched this one around a little bit. So in order to do that, you go to the statement of the probability of A is equal to probability of A intersected with B plus the probability of A intersected with B not. So again, it's the exact same formula. The nots are just on the B now as opposed to the A. So you can go either direction and it doesn't change the order or anything about it. So this is a pretty quick and easy deal. Again, you get the probability of A intersected with B is equal to the probability of A minus the probability of A intersected with B, which is equal to 0.3 minus 0.1 is equal to 0.2. So not too bad. You just have to know that in order to get the probability of A, you use this little property. And it is a formula to have to remember, but it's really handy for a lot of stuff. Okay, so now moving on to part B. Make sure I get the right one here. All right. Probability of A union with B not. Just like that. Okay. So this one's actually pretty easy because we know the A union of B is whatever it was. We found it up here, 0.4 right here. We found A union of B up here, which is 0.4. So in order to get not, you just take 1 minus the probability of this entire gig, which is equal to 1 minus probability of A union B. So 1 minus 0.4, which is equal to 0.6. Bada bing, bada boom. There you go. Now, one last one. We have the probability of A naught union with B is equal to the probability of A naught, this is another property here, of probability of B minus the probability of A naught union B. So, this setup is exactly like the one we did before with the chart, the table up here that I illustrated. Because whenever you have a union of two probabilities, you have to take out a chunk of that probability so you're not counting something twice. So in this case, we have the probability of A, we have the probability of B. We're doing the union of them, but if we just were to do that, then we'd have an overlap in the probabilities so that you would be counting something a few too many times and giving yourself a higher probability than there actually is. So this is just a little proviso catch-all to clean up the extra stuff and kill it. So this is equal to 0.7 plus 0.2 minus 0.1, which is equal to 0.8, or 0.8 if you like that. And there you go. That's how to find unions and intersections of probabilities where the value of the probability is given.